Hello everyone, welcome to Artistic Atom channel. I'm Fatima and in this session we will discuss check your progress question answer from properties of materials chapter in Cambridge Lower Secondary Science Learners book 9. So let's get started. The question 1 is the table shows some information about four elements. These elements are from the same group in the periodic table. They are given in the same order as in the periodic table. So here this information given is very important because this will help us in solving these questions. So the question 1 is the melting point of sodium is. So here we are expected to write the exact melting point of sodium. But if we look at the given table, we can see that the melting point of sodium is not given. So here what you will write as an answer? Well, here you are expected to write the range of the temperature between which the melting point of sodium can lie. So if we look at the trend given over here, we can see that as we move down the group, the melting point of these elements decreases. So this means most probably the melting point of sodium will be less than 180 degrees Celsius and greater than 63 degrees Celsius. So this is what you are expected to write over here. Now the next question is the boiling point of potassium is. So if we look at the boiling point column given over here, we can see that the boiling point of potassium is not given. So here also you're going to use the range. So if we look at the trend in the periodic table given over here, we can see that as we move down the group, the boiling point of these elements decreases. So this means the boiling point of potassium will be less than 883 degrees Celsius and greater than 688 degrees Celsius. This is what you will write as an answer over here. Now the next question in this is the elements all react with water to produce gas. Name the gas. So here we have to write the name of the gas which is produced when these four elements they react with water. So in your textbook these reactions are given where they have shown you how these elements react with water and produce hydrogen gas. So whenever these elements react with water, they form their respective hydroxide. Along with that, their hydrogen gas is released as a byproduct. So you are expected to write the name of that gas which is getting released during this reaction. So the name will be what? Hydrogen gas. Now the next question is use the information about the reaction with water to predict the reaction between sodium and water. Here you are expected to write the nature of the reaction that uh, will happen between sodium and water. So if we look at these four reactions, okay, I'm making it usual to you so that you can imagine how exactly the reaction between these four elements and water will happen. So if we add lithium to water, you can see that there are small bubbles that you will observe over there, slight fizzing, okay, not a vigorous reaction. But if you look at this reaction where sodium is added to water, you can see that there is a vigorous reaction. You will see a strong amount of bubbles evolving in the water. At the same time you will see small sparks. But if you look at the reaction between potassium and water, you will see that the reaction is quite violent than that of sodium and water's reaction. And if you look at the reaction of rubidium with water, you will see that rubidium reacts extremely violently and hence you will see an explosion over there. So this means the nature of reaction is what over here? You will see small vigorous bubbles arising in the water. At the same time you will see slight fire, or you can, why this fire is there in this particular reaction? The reason is because this reaction is what? Exothermic. So the huge amount of heat is released. So depending upon the amount of heat is released, the nature of the reaction will be that violent. So as an answer you will write this over here. So what you will write? You will see more bubbles of gas, more heat will be generated than that of lithium, but it will be less than that of potassium. So this is how you will answer this question. So the next question is the following are the mass numbers of the four elements in the above table, and we have to write down the exact match numbers with their respective elements. So in order to solve this question, there is some information that you're expected to know. So I will just take you through that information so that you will understand the background knowledge that is required for this question and will be able to solve this question very easily. So now when we look at this image, we can see that as we go down the group, what happens is the number of electrons increases, and as the number of electrons increases, their number of shells also increases. So in conclusion, we can say that as the number of electrons increases, number of shells also increases, and we can clearly see that the size of that atom is increasing. Here there is second point that you are expected to know. That point is number of protons are exactly equivalent to the number of electrons. So this means if I say number of electrons are increasing, this means the number of protons also increases. And if we calculate the atomic mass number for that respective element, we have to add the number of protons plus number of neutrons. So now if the number of protons increases for that respective atoms, as we are moving down the group, atomic mass number will surely increase. So this means if we are moving down the group, the size of these elements increases. So with increase in the size of these elements, their atomic mass number will automatically increase. So using this trend, we can easily solve this question. So this means according to this information, if we calculate their atomic mass numbers, we can clearly see that for the element which is lower in the group will have the highest atomic mass number, and the element which is highest in the group will have the lowest atomic mass number. So using this information, we can clearly conclude that down the group atomic mass number increases. Why it is increasing? Because number of protons and number of neutrons also increases. So in conclusion, we can say that this highest atomic mass number is of rubidium because it is lowest in the group. 39 is the atomic mass number for potassium because it is the second last element in the group, and then we have 23, which is the atomic mass number for sodium, and 7 is the atomic mass number for lithium because it is highest in the group. And as it is highest in the group, it will have less number of protons, less number of neutrons, due to which its atomic mass number will be the least. So you have to remember this information to solve such kind of questions. So this will be the answer. Now the next question is, what does the mass number tells you about the atom of each element? Well, as we have discussed just now, when we talk about atomic mass number, it is the sum of number of protons and number of neutrons. So it will tell you how many number of neutrons and how many number of protons are there, or in general you can say that the sum of proton and neutron can be obtained by their atomic mass number. So as you can see over here, this is how you will write down the answer for this question. Now the next question is, lithium has 2 electron shells. The electronic structure is 2, 1. So this can be seen in the diagram below. So here's how they have drawn the electronic structure for lithium. So sodium has the electronic structure 2, 8, 1. Draw a similar diagram to show the electronic structure of sodium. So here you are expected to write the atomic structure for sodium. They have also given you the exact electronic configuration. So with which this is called as the electronic configuration, or you can say electronic structure. So with this you will understand how many shells are there. So since here we are provided with 3 values, this means there are 3 shells present. So firstly what you will do, you will draw a nucleus, then you will draw 3 shells. Then in the first shell, how many number of electrons are given? 2. So you will draw 2 electrons. Then in the second shell you are having 8 electrons. Then in the outermost shell you will have 1 electron. So this is how you're going to draw the answer for this question. Now make sure to draw the nucleus, because if you're not going to draw this, then this will not be considered as an atom. So you will lose marks over there. Now the next question is, the fluorine atom has electronic structure 2, 7. This is shown in the diagram below. So here is the atomic structure diagram given for fluorine. So you have to draw a similar diagram to show the electronic structure of a fluorine ion. Now when we talk about ion formation, how the ions are formed. So ions can be formed when there is loss of electron or gain of electron. Now as we know that fluorine is a non-metal, hence it will accept one electron. So if we look at the diagram for fluorine atom, then we can see that in first shell it has 2 electrons, then in the outermost shell it has 7 electrons. So it's easy for fluorine to accept 1 electron and complete its outermost shell. So this fluorine will accept 1 electron. As soon as it will accept 1 electron, it will carry negative charge. This negative charge indicates that that particular atom has gained an electron. So suppose if that particular atom is losing an electron, then it will carry what? Positive charge. So this is how you will draw atomic structure for fluorine ion. So make sure to remember that whenever the number of electrons are gained, you will write down what? Negative charge. If the number of electrons are lost, then you will write what? Positive charge. Now the quantity or the magnitude of that positive and negative charge will depend upon the number of electrons that that particular atom is gaining or losing. So here, since fluorine has just gained 1 electron, so the symbol will be what? F minus. So suppose if magnesium is losing 2 electrons, then you will write what? Mg2 plus. So this is how we write their symbols, and this is how we draw the diagram for this particular question. So now the next question is, why is fluorine ion more stable than a fluorine atom? Well, it is clearly visible in this image, because when it is existing in the form of fluorine atom, we can see that the outermost shell is not complete, and these elements, they undergo a reaction in order to complete their outermost shell, because it provides them the stability. Hence when it acquires 1 electron, then the outermost shell of this fluorine atom gets completed, and hence it will become more stable than that of fluorine atom. That's why the fluorine ion is more stable than that of fluorine atom. So here is how you will write down the answer. Now the next question is, the symbol for fluorine atom is F. Write the symbol for fluorine ion. As I told you, since this fluorine is gaining 1 electron, we will write down its symbol as what? F minus. Now the next question is, for each of the following, state whether this applies to a substance with covalent or ionic bonds. So here they are provided us with different kind of combination, that is metal, non-metal and other combinations, and we have to determine what type of bond will be formed between those elements. Okay. So for this, we have to first understand how many types of bonding we have. So according to your grade level, you are expected to remember these two type of bonding. So first is ionic bond and second one is covalent bond. So ionic bonds are formed whenever we have ions present. So as you can see over here, I have a metal and I have an atom of non-metal. So what will happen in this case is, this metal will lose its electron completely. So as soon as one element is losing its electron, it will carry what? Positive charge. And whenever an atom is accepting an electron, it will carries what? Negative charge. So when this atom carries positive charge, we call it as what? Cation. And when this atom carries negative charge, we call it as what? Anion. So when these cations and anions are formed, they attract each other via electrostatic forces of attraction, and hence results in the formation of what? Ionic bond. So it is necessary for ionic bond formation that there has to be presence of what? Cation and anion. So once the cation and anions are formed, then only it will result in the formation of what? Ionic bonding. Now the next type of bond is what? Covalent bond. So covalent bond is, in this case, there is no formation of cation and anion. Here there is just sharing and pairing of electrons. So these atoms, they just share their electrons and pair it, and that pairing will result in the formation of what? Covalent bond. So if we use this information, then we will be able to solve these questions very easily. So the question A is, when a metal joins with a non-metal to form a compound. So here we have to understand how exactly a metal forms a bond with a non-metal. So here I have taken an example of a metal, and here I have taken an example of a non-metal. So this metal will lose one electron and this non-metal will accept that electron. So as this metal is losing one electron, it will carry a positive charge, and now it will be called as what? Cation. And since this species is acquiring that electron, that's why it will gain what? Negative charge, and we call it as what? Anion. So when these oppositely charged carrying species comes together, they attract each other via electrostatic forces of attraction and results in the formation of what? Ionic bond. This means whenever we have a metal joined with non-metal, that bond is always what? Ionic bond. Now the next question is when two atoms share electrons. So for this I have taken example of hydrogen. As you can see over here, here we have one hydrogen atom and here also we have one hydrogen atom. So these two hydrogen atoms, they will share and pair those electrons and results in the formation of what? Covalent bond. So this means hydrogen, or we can say a non-metals, when they bond together, they bond via what? Covalent bonding, because there is no formation of cation or anion. They just share and pair those electrons. Now the next question is when two non-metals join together. So here hydrogen is an example of non-metal. Why it is called as non-metal, considered as non-metal? Because hydrogen shows most of its properties similar to non-metals. Even though it is listed in metals, alkali metals, but it completely shows properties of non-metals, hence it is considered as what? Non-metal. So when we react this non-metal with this non-metal, what will happen? It will result in the formation of what? Covalent bond, which we have discussed just now. Now the next question is when a compound that is dissolved in water conducts electricity. So when we have a compound which is completely dissolved in water and then it conducts electricity, what type of bonding will it show? In order to understand this question, I have taken two examples. Now here I have dissolved NaCl in water. Now as we know that Na is what? Sodium, and Cl is what? Chlorine. So sodium loses its one electron, whereas chlorine, it acquires that electron and hence results in the formation of what? Na plus and Cl minus. So this means here we have what? A cation and an anion. So since we have formation of charges, as soon as we connect it through the external circuit, it will result in what? Formation of what? Electricity, and hence we will see that the system is conducting that electricity. Now if we look at this mixture, so what will happen when we add sugar into water? The sugar will completely dissolve in water, but there is no formation of charges because sugar is formed, the atoms in sugar are connected to each other via covalent bonding. There is no formation of ionic bond. So when we connect it through the external circuit, we can see that it is not conducting electricity. So this means if a compound is conducting electricity when it is dissolved in water, then surely that particular compound is what? Ionic. I think so you have understood this concept through this example. So here the answer for this particular D question will be what? Ionic bonding. Now the next question is when atoms gain or lose electron. This is the same thing that we have discussed in the first one. Here we have an atom which is losing an electron. Here is an atom which is gaining that electron, resulting in formation of what? Cation and anion, which then attracts each other via electrostatic forces of attraction, which is nothing but what? Ionic bonding. So in conclusion, we can write these as an answer for this question. Now the next question is the diagram shows a molecule of methane. Write the formula for molecule of methane. Well, whenever you're writing a formula for any of the compound given, you're just expected to count the number of atoms present and write those atoms in this form. So that is what is called as what? The molecular formula for that particular compound. So if we count over here, we can see that there is just one carbon and there are 4 hydrogens present. So this is the molecular formula for what? Methane. Now the next question is the diagram shows the lattice structure of sodium chloride. what holds the lattice together. So here, as we have discussed just now, whenever we have cation and anion present, they both attracts each other via electrostatic forces of attractions, and those forces of attractions is nothing but their ionic bonding. Okay, so this means that particular whole lattice is held together just because of what? Electrostatic forces between the positive sodium ions and the negative chlorine ions. Now the next question is, what does this lattice structure tells you about the melting point and the boiling point of the sodium chloride? Always remember, if the atoms they are strongly held together, then you will require more amount of energy to break that particular crystal lattice, and as you're requiring more energy, this means the melting and the boiling point will be higher for that particular compound. So since here there is formation of ionic bonding, and we know that ionic bonding is stronger than that of covalent bonding, hence the melting and the boiling point of these ionic compounds will be higher than that of covalent compounds. So in conclusion, we can write this as an answer. Now there is exception of diamond, because diamond shows presence of what? Covalent bonding, but still due to its highly networked structure, the melting point of diamond is the highest among all the elements. So there are some exceptional cases, but in general you can remember this information, as the ionic as the bonding between those particular those atoms or ions increases, the amount of energy required to break that particular crystal lattice will be higher. Hence we can conclude that ionic bonding is stronger than that of covalent bonding. I hope you have understood everything whatever we have discussed till now. So with this we have completed our session. Thank you so much for watching. Do like, share and subscribe to my channel Artistic Atom. See you in the next session.